So, first question. Get started and submit your answers, right? Roughly about 5 minutes for every question. Right? Write it down also, right? Write down the question and then start. Question. So whenever we're doing this topic, we have to ensure whoever is touching x squared, the a value, well, we have to make sure it's 1. Now, you will see that in today's question, we have 2x squared. So that's a problem right there. So I believe in the videos, I told you whenever over here we have a value, instead of 1, we divide out throughout by that value. So today's value is 2, but we have to divide out throughout by 2. So when we do that now, the 2 and the 2 will cancel here, right? So we're left with what? X squared minus 3 on 2. And of course, minus 5 on 2 is equal to 0. It's up to you if you want to leave it as what? Fractions, or you want to put it as decimals or mixed fractions, right? But I think everyone here in Add Maths class, we know 3 divided by 2 is 1.5 and whatnot, right? So the first one asks you for the sum of the roots. Now the sum of the roots is alpha plus beta. That's this formula here. Now, in the videos, I stressed on this. Now, alpha plus beta, we just need to look at x and ask who is touching x. Now, signs are super important. But the alpha plus beta is always the opposite of who is touching x. Do you all remember that from the videos? I said whoever is touching the x for alpha plus beta. I never seen it over and over. It's always the opposite. So it's supposed to be positive 3 on 2. At least half the submissions, people left what here? The minus sign by mistake. So the answer for the sum is 3 on 2. For the product, this is the one where you take it as it is. You don't make it the opposite. You have to look at the value without the x. And if it's negative, you have to leave it negative. If it's positive, it's what? Positive. So this one, the minus sign remains. All right, so if you have positive 1.5 and negative 2.5, you are correct also. All right, so for those who got it wrong, take down the correct answers. For those who got it correct, congrats. All right, so take a 20 seconds and then we'll move on to the next question. All right, so this one looks a little bit scarier, but it is doable. What you're going to have to do first is obviously get rid of those brackets, right? So we have to expand those brackets. So you have ax squared plus 8a, and then every one inside here gets multiplied by x. So 1 by x is just x. You can put the 1 if you want to, but you don't have to. And 2a by x is minus 2ax. The other problem here is that for this topic to work, for the formulas to work, sorry, everybody has to be on the same side of the equal sign. In other words, this side must be equal to 0. So you have to like begin throwing across everybody on this side. So that is the first, that is the next step. If you do that, right, then you're going to end up with ax squared. You'll end up with positive 8a. Well, he was always there. You throw across positive x, you get minus x. You throw across minus 2ax, you get positive 2ax. Then it's equal to what? 0. But you gotta be careful. Remember, this is a quadratic. Quadratics is have the x squareds in one place all the x's in one place, and then everything else without x's by itself, right? So you have to organize this to make it look like a quadratic. In other words, you group all the x squareds together, you group all the x's together, and then who doesn't have an x, throw them last. Okay, so take it from there and let's see what you come up with. Remember, we need to group all the x's together, right? Let me give you a scenario. If I have 3x squared plus 2x plus 7, and it's equal to 0. And I ask you how much is A. Isn't A the person touching x squared? So it's real easy to say A is 3. If I ask you how much is B, well, by now everybody knows in a quadratic, whoever is touching x is what? B. So B is positive 2. And then who doesn't have an x is C. I think that's standard knowledge by now. But what about this? If I have 3x squared plus open brackets 4 minus k, I'm just saying something weird like that. And I ask you how much is A? Well, whoever touching x squared is what? A. Whoever is touching x. Now remember, this whole thing is touching x. So that would be what? B. So B is 4 minus k. But that is how you identify x. You have to ask yourself, who is touching x? Sometimes it might be one item, but sometimes it might be a group of items. And well, this one here, C is what? 7. And I have a good feeling this is how this question is going to end up being, right? So you have ax squared, so we have him over there, but we have 2 items with x. So we could probably put these 2 in the middle. So we could put 2ax, and I just put the minus x after, right? And just switch it around, no harm done there. And you put the 8a afterwards. Now we can't have 2 x's, because if you have an x here and an x here, well, you don't know which one is B. You must only have one x in the scenario. So couldn't we just factorize out the x? Look at this. And we could pull out the x from here and pull out the x from there. We'll get 1 here. And who goes outside? X. Everyone sees that? We had factorized out the x. So now we can identify who is A. Well, we have a little problem, right? We know this is A, we know this brackets is B, and he is what? C. Can these formulas work? Well, what do you all think? Can those formulas work? The answer, right, Kenya, correct. The answer is no, because for this to work, whoever is touching x squared, it has to have a 1 here. So we have to divide out throughout by A, right? And only when we divide out throughout by A, well, we have a 1 here now. Well, no, I'm not going to even bother to divide everyone on top by A. I'm just going to leave it as one big divide sign. And over here, the A and the A will cancel out. So now, look how neat this looks now. You have x squared plus 2a minus 1 on A. You have a x here, and then you have Mr. 8 here. How much is alpha plus beta? Alpha, alpha plus beta. Remember, once you have a 1 here, it's the opposite of who is touching x. So how do you make something the opposite? You just put a minus sign in front of it. So you can put it like this. Minus open brackets 2a minus 1 divided by A. You will get that correct in the exam. Or you can multiply everyone in the brackets by a minus sign. So you'll get positive 1 here and minus 2a. The examiner is not going to judge you too hard. This is considered 100% correct in the exam. And then alpha plus beta, sorry, alpha multiplied by beta, the products is this guy here. For those who got it wrong, you understand it now. And you notice my final answers, My final answers do not have the letter X in them. I see a lot of people put an X here and they put an X here, right? It will not have the letter X in your final answers, right? Right, so take down the working and we will move on to the next question. Right. Next question. So I hope you all find these pictures relaxing. All right, get started with this one question. All right, so we're trying to get back the original quadratic, right? So it's x squared. You're going to have something touching x here, and then you're going to have something without x here. To get back this value, what we have to do, we have to add. Well, so no, this question is pretty easy. I'm not realizing this. I won't even need a calculator. They already gave you the sum of the roots, right? So to figure out what is touching x, remember the sum is this one here. So you have to put what? The opposite of this value next to x. So you're getting positive 2 on 3x. And the product they write out gave you it as what? 5. So we cannot leave it like this. Whenever you have a denominator, in the videos I showed you that you need to multiply out throughout by the denominator. So this 3, we have to multiply every one by 3. And if we do that, we'll get 3x squared. The 3 and the 3 will cancel out to give you 2x plus 15. This is the one CXC will want to see. They will not want to see the green one, right? Only 1 or 2 people forgot to change the sign for the middle. Some people had put negative 2 on 3 by mistake here. Remember, it's the opposite of it that goes next to the x. Right? Right, so take down the working. Hopefully the next one is harder. All right, so this one here will be a challenging one, right? I'm not working out the whole question. It's just based on the answers I'm getting, right? I think a lot of people are misinterpreting the question. So let's give you a little jump start here. We have a quadratic. Well, you see it's written on top here, right? So we know we have to at least do what? Divide out throughout by 2. I think everyone gets that concept now. So if we divide out throughout by 2, we'll get x squared, making here 1. If we divide 5 by 2, but I'm going to put a decimal today, so we get 2.5x. And then minus 6 divided by 2 is minus 3. So, right, this particular quadratic, if we add alpha and beta, we will get minus 2.5. I think by now everyone knows is the opposite here. And if we multiply alpha by beta, we get in minus 3. But some people are sending these answers. That's not the answer for the question. What they are saying is that there is a new quadratic whose roots are alpha plus 1 and whose roots is also beta plus 1. So if a quadratic has different roots, when you work backwards to find the quadratic, it will look different from this quadratic, because you can't change the roots of a quadratic and expect it to look the same. If you change the roots, then the quadratic will also change in looks or value, right? If you kept it as a fraction, no problem. If you have minus 5 on 2, not a problem, right? But I just think in today's question might be a little easier if you use decimals, right? But you don't have to, right? So this come like the new alpha and this come like the new beta. I believe in the videos I would have put alpha 1 and beta 1, right? Right, so give you just a couple more minutes to get back on. Right, so I just want to help you a little bit. So to figure out who is touching x in the new quadratic, we have to add alpha 1 and what? Beta 1. And when we add these two together, we have to take the opposite of that answer. But the thing about it, alpha 1 and beta 1, alpha 1 is really what? Alpha plus 1. Plus, that is this plus sign here. And beta 1 is beta plus 1. If you simplify that, you will get what? Alpha plus beta. If you add alpha and beta, we can't really do anything there. And then 1 plus 1 is what? 2. Right? And remember, we have a value for normal alpha plus beta. What's the value for normal alpha plus beta? Minus 2.5. So we kind of using the original quadratic to assist us with the new quadratic, right? We're going to steal values when possible. So alpha plus beta is minus 2.5, and then we have to add 2. Now I can do this in my head, right? And we'll get minus 0.5 or minus a half. So we know who is going to touch x now, the opposite of this. So positive a half is going to touch what? The x. I'll just help you a little bit. So how you're going to figure out what is the c value? Well, we have to take alpha and multiply it by beta 1. And remember, alpha 1 is alpha plus 1, and we have to multiply it by what? Beta plus 1. You have to multiply all these brackets, right? So try your best to multiply all those brackets and simplify it, and then see if you could steal values from above to assist you. So let's just see if you multiplied all the brackets correct, right? You'll get alpha by beta is just alpha beta. 1 by beta is beta, and then you get alpha by 1. So you'll get an alpha plus what? A beta, and 1 by 1 is 1. Everyone can agree with that when you multiplied all the brackets, right? Great. And you could see from above, you could clearly steal values. Look at this. Alpha multiplied by beta, isn't that equal to minus 3? Isn't alpha plus beta, isn't that equal to what? Minus 2.5? So you could throw away this, replace it with minus 3. Throw away this middle, replace it with minus 2.5. And whatever you get, you add 1 afterwards. All right, so what we have here is minus 3. Alpha plus beta is minus 2.5, and then we have to add 1. So minus 3 minus 2.5, add 1, I'm getting minus 4.5, or 4.5 is minus 4.5. But if we put that in a improper fraction, we'll get minus 9 on 2, right? Right. Now remember, when we substituted it in, we should put the fractions, because we'll need to get rid of the denominator. All right. So when we substitute it in, you'll get x squared. Who is touching x? The opposite. Even the formula up here tells you to take the opposite. You notice it have a minus sign here. Whenever you put a minus sign in front of something, it really means take the opposite, right? So you'll get positive a half what x. And this one here, you just take it as it is, right? But we can't leave it like this, right? We need to get rid of the denominators. So we need to get rid of the 2's. So we have to multiply out throughout by what? 2. If we do that, we'll get rid of the denominators here. So the 2 and the 2 will cancel out the 2 and the 2. And so you end up with 2x squared plus 1x. We don't have to put it 1 minus 9, right? So double check your answers. Some people had minus 7 here by mistake. Some people had 4 here by mistake. Slight mistakes, right? So double check it. Let me know when you're finished checking it over. All right, so this was a slightly harder question, but it is a possible past paper question. Right, so this one here is a little bit challenging, right? I couldn't resist putting this one. So I think the first thing we have to do is divide out throughout by 2. So if we divide out throughout by 2, we're going to get, well, we're dividing him by 2. Well, that's a bad color there. That's the one. We should divide everyone throughout by 2. Now, if we do that, we'll get x squared minus a half x, right? Remember, this is already a 1 on top here, right? Plus c on what? 2. So I guess that is the first step. Now, they are telling us, well, we all know it have 2 roots, alpha and what? Beta. Those are the 2 roots. But they're saying one root is twice the other. So tell me if this makes sense. Is it possible to write the 2 roots like this? Instead of beta, and we could put 2 alpha. Isn't 2 alpha twice alpha? What do you all think about that suggestion? In other words, we will get rid of B. There's no need to write what? A beta, right? I don't know if you also saw an easier way to do this, but this is the first time I work in this question, actually, right? So this is what I would do in the exam, right? So apparently, if you add alpha and beta, but the beta is what? 2 alpha, you will get what? The opposite of who is touching x, which is positive what? A half. And if you take alpha and multiply it by beta, but remember beta is now 2 alpha, you will get what? C on 2. Tell me if you understand up to there. Alpha plus beta always gives you the opposite of who is touching x, and alpha multiplied by beta always gives you the value who is touching what? Who doesn't have an x attached to it, the c value. So it seems to me you have a pair of simultaneous equations here. Don't let alpha plus 2 alpha get to you. Isn't that 3 alpha? And you can easily solve for alpha and then substitute them inside here. Think about it. This come like equation 1. This come like equation 2. You can easily solve for alpha in equation 1. Let's try to simplify these equations. Remember, alpha plus 2 alpha, that's how much? 3 alpha. So I guess I could summarize that to what? 3 alpha. I don't know what I was trying to write there. This here is a multiply. We could throw it across. It will go underneath, right? So it will become a divide underneath the 1 here. So you'll get 1/6, right? So therefore, alpha is 1/6. All we have to do now is substitute it inside here, right? Now, it's pretty easy, right? Number alpha multiplied by 2 alpha is 2 alpha squared is equal to c on 2, right? But before I substitute it in, I could probably just cross multiply. C by 1 is what? C, and 2 by 2 alpha squared is 4 alpha squared. All we have to do now is just replace alpha in brackets with what? 1/6. Now let's see what you get here. So you get 4 multiplied by 1/6 squared. Right? I believe when you work this out on a calculator, you're going to get 1/9 or 0.111111111, right? Which is the same thing as what? 1/9. But make sure you physically see 1/9, okay? Right? You can do this by hand too, right? 1 squared is 1, 6 squared is 36. 4 into 36 is 9. All right, so let's move on. Let's see what's next. All right, have fun. This one was almost, remember the question with how we had alpha plus 1 and beta plus 1 before? This one is almost like that one, except they put in alpha plus 3 and beta plus 3. That is the only difference there, right? So it's a good chance to practice back that question with a different value in case you got the first one wrong, right? The chance of recognition. 3. So when we divide by 3, we're going to get this. We're going to get x squared. We divided everyone here by 3. So you'll get 5 on 3. Do not put this as a decimal. That'll give you what? 1.6666666. Leave it as the fraction. And then you get what? 1/3. Now, a lot of people are getting confused by this, right? The hx squared. You can ignore this. What they're really trying to tell you is that the new quadratic has new roots. And of course, since it has new roots, the quadratic will look different. So at the end of the day, you're just trying to find the new quadratic. You don't even have to pay attention to this statement over here while you are doing the working. So what they're trying to say is that when you add alpha and beta, you're getting -5 on 3. And if you decide to multiply alpha by beta, you will get what? 1/3. Everyone okay up to there? Like that's we're far from finishing the question, right? Great. So you have 2 new roots, the alpha plus 3, and the next new root is beta plus 3. So this comes like the new alpha. So you call the alpha 1, and your key is what? Beta 1, right? So I'll give you some time from there. Yeah. So to figure out who is touching the x in the new equation, we're supposed to take alpha 1 and add it to beta 1. And whatever we get, we take the opposite of that. So we have alpha plus 3 plus beta plus 3. When we summarize this, we could probably put the alpha and beta together. Alpha plus beta, and then 3 plus 3 is 6. We know from up here, we could steal the value. Anywhere we see an alpha plus beta, we can replace it with -5 on 3, and we can just add how much? 6. So -5 on 3, right? Let me see if I can do it on my calculator here to show some of you who don't know how to use the fractions button. All right. If you put -5, you press the ABC button, ABC 3. You just press equal, and then you add 6. You'll get what? 4 and 1/3. So 4 and 1/3, or 4 by 3 is 12, or 13 on 3. How much people got that? Of course, we have to take the opposite of this value and put it next to the x. Okay. So I hope we're on the right track here with this question. Next on the list now, to get k, well, k is who? Who is not touching the x, the c value. We have to take alpha 1 and multiply it by beta 1. Alpha 1 is alpha plus 3, and we have to multiply it by beta plus 3. So for those who didn't reach here, you can take your time now and multiply out the brackets. Alpha by alpha beta is alpha beta. You'll get 3 alpha plus 3 beta plus 9. Now, if you look in the middle here, right, you realize you can factorize out the 3, and we'll need to factorize out that 3, because when we factorize out the 3, we'll get alpha plus beta, and then we have add 9. The reason we need to factorize out the 3 is because alpha plus beta is minus 5 on 3. So we had to kind of like single it out, to separate it from the 3. So substituting your values, alpha beta is how much? 1/3 plus 3 in brackets here. You have minus 5 on 3, and then you have this annoying plus 9. So you need to work this out, and let's see what you get. So I have 1 ABC 3, that is 1/3, that is this here. Nope, something went wrong there. 1 ABC 3, so it's 1/3 plus 3 multiplied by, but I'll put this in brackets here, minus 5 ABC 3, close brackets, press equal, and then add 9. Did you all get 4 and 1/3? When you work this out, 4 and 1/3, or 13 on 3. Right, so all we have to do now is just substitute in the values in the correct places, right? So if we do that, I was closing this calculator, won't need it right now. So put a line here. So we have x squared. Who is touching x? The opposite of this number here. So you get minus 13 on 3x plus 13 on 3. Right? I think this question had a mistake. I don't think this is the answer here, but when we multiply out throughout by 3, because we need to get rid of these things here. So you multiply here by 3, multiply here by 3, multiply here by 3. We're going to get 3x squared minus 13x plus what? 13. Right? Right. So the values of h is how much? H is what? 3, and k is how much? 13. I believe they made a mistake here. In the middle, they were supposed to have minus 13 here. They made a mistake, right? So watch through the working and make sure you see your mistakes. Kenya, well, we passed there a long time. All right. All right. Have fun with this one, right? So this one here now, You have, he's alpha 1 and he is what? Beta 1. That is what they're really trying to say. And look how nice the examiner is. The value touching x squared is already 1. So that's good news. Yeah, no problem, Ursuline. Okay. Right, so I have most of it lined up here already, right? But the problem is we have alpha squared plus beta squared. But this is one of the formulas we're supposed to learn off, right? Anytime in this topic, anywhere we see alpha squared plus beta squared, it's not a problem. We could just throw him away, right? And replace him with alpha plus beta in bracket squared minus 2 alpha beta. And then we have this 2 alpha beta here. But this is really good news. Minus 2 alpha beta plus 2 alpha beta. Won't those two things cancel off? Leaving you with what only now? Alpha plus beta squared. And we have a value for alpha plus beta. So we could throw away this in the brackets and replace it with 2. And 2 squared is what? 4. All right? So that part is pretty much complete for you. Right? So you have the 2 here. So when you work that out, you will get what? Well, I guess I could put it here. You'll get 4. Right? Even if it didn't cancel, you'll get 4, right? But it will save your working if you realize these two would have just canceled out. So now you still have plenty of work ahead, right? You still have to work out what? Alpha 1 multiplied by beta 1. The first statement was from up here. Remember, alpha plus beta is the opposite of who's touching x. And alpha multiplied by beta is this one here. Remember, whoever touching x, the number touching x squared is already 1. So we don't have to divide out throughout by anything. All right, I just had to share back the screen. Yes, now, guys. All right, so we're running out of time. So I just want to make sure I get this piece here now, the alpha beta 1, right? The alpha beta 1 is, let's see, alpha squared plus beta squared. And we have to multiply that whole thing by beta 1, which is 2 alpha beta. Let's see what happens over here. Every one inside here gets multiplied by 2 alpha beta. So you'll get 2 alpha cube beta. No, I think that would be too complex. We shouldn't multiply all the brackets. And we can replace this with something, and we can replace that with this statement once again. So I think we should do it like that instead. It will be way, way easier instead of multiplying all the brackets. So inside the brackets, you can replace it with what? Alpha plus beta squared minus 2 alpha beta. That whole thing is in brackets, and we have to multiply by what outside? 2 alpha beta, right? So you can replace this with a value, replace this with a value, and replace that with a value. Right. 2 squared is 4, so you're getting 4 here. 2 by 3 is 6, a minus and a minus and a plus. So inside the brackets, you're getting 10. 4 plus 6 is 10, and then you're multiplying it by minus 6. So I think we're getting what? Minus 60. Right, and a lot of people did agree with that. Oops, sorry about it. Right. So make sure you physically see it on your calculator. So that means we didn't get any fractions this time. So that means our final answer would be what? X squared minus 4x. We have to take the opposite of this guy. And then minus 60 is equal to 0. That's the quadratic they're looking for. Right, so this one was a complicated one. I don't think I have ever seen one this complex in a CXC exam as yet, but it's not off the syllabus, right? It's definitely not off the syllabus. But sometimes teachers in term tests will bring complicated questions like this. They're just to get you prepared, super prepared just in case. All right. Now, the next topic I'm planning to do, I haven't decided as yet. I'm weighing in between trigonometry or APs and GPs, somewhere there. I haven't chosen as yet, but next week when you come, you'll see which one I chose, right? So once you get the answer and you understand, you're free to leave, right?